All right, this is 1.8, which talks about the coordinate plane. So if you take a look into this picture, we need to make sure that we know what certain things are in a coordinate plane. And why are we doing things like this in geometry? Well, the nice thing about the coordinate plane and certain formulas is that we can prove certain geometric postulates and theorems by using this information. So I want you to take a look at this graph below. And the first thing that you should already know very well from algebra class is that this is the x-axis right here, and this is a y-axis. Okay. You should also know that this center of the x and the y-axis is called the origin, which is right there in pink. So each of these little pieces have names, like this quarter piece up here, the main part of the graph that we look at, which is here. This is called quadrant 1, where you have positive x values and positive y values. And then we just move in a counterclockwise position. So then over here, we have negative x values and positive y values. And this is called quadrant 2. And then as we keep continuing to go around here, these are just knowing the names of each quadrant. So this starts as quadrant 1 here, and then it moves to quadrant 2, quadrant 3, and quadrant 4. So those are just some names and some notation that you will need to know. The next thing that we need to know how to do here is how to use what's called the distance formula. And when we talk about a coordinate plane, if I want to know the distance between any two points, not just by counting boxes, but anywhere on my plane, I can use this distance formula to determine the distance between it. And this is what it looks like. So it is a little intimidating, but I'm going to walk you through it one by one so you will see how to work with it. So let's take an example. So let's say I've got the 2 points 5, 2 and -4, -1, and I want to know the distance between them without using a graph, without even counting boxes, just by using this formula. Well, here I've got two different x coordinates. I have this one, which I'll call x1, and this one, which I'll call x2. And if I look up in the formula, I see that x2 is right here, and x1 is right here. So all I would have to do is very simply fill in the numbers that would go there. So we'll get there in just a second. And I have a couple y values as well, so I'll call this one y1, and this one y2, which happen to be right here. And that is all I need to use for the distance formula. I just need two coordinates, because you see here, everything's spelled out. This d here over here stands for the distance that it represents. So I am going to go ahead and I'm going to copy this formula, but I'm going to fill it in as I go. So the first thing is x2, which is -4. So I'm going to write that in here, -4. And I'm going to be subtracting x1 from it, which is 5. So all I'm doing right now is rewriting this. And that difference is going to be squared. And I'm going to do the same thing for the y value. So y2 is -1. And I am going to subtract y1, which is 2. And this difference is also squared. So this is all going to break down into something much simpler. So this very first difference is -4 minus 5, which happens to be -9. And let's look at this other difference. -1 minus 2 is -3. And we're going to simplify this even farther until I can't simplify anymore. So -9 squared means -9 times -9, which is positive 81. And I'm going to add that to -3 squared, which is 9. And what this is going to give me is the square root of 90, which is approximately, the two squiggles mean approximately, 9.487. And you can leave your answer in radical form if you would like to, but you need to make sure that it's simplified. And if you don't remember how to simplify it, we will be going over that later. So that's how we use the distance formula. There's another form that we want to look at, which is called the midpoint formula, which is used to find the very middle of any two coordinates, which looks like this. And if you look at this closely, this looks like a coordinate. This piece right here is going to be the x-coordinate of my midpoint, and this is going to be the y-coordinate of my midpoint. And it also makes sense that I'm dividing both of these by 2, because if I want something split right in half, that's what I do. I divide it by 2. So let's take those same two coordinates again and find the midpoint. And as you see here, I've already color-coded my x1 and x2 and y1 and y2. So all I have to do now is fill in what needs to be filled in. So I'm going to start with x1 plus x2. So that's going to be 5 plus -4. And that's all divided by 2. And I kept my negative number inside parentheses just to make sure I don't make any mistakes with it, since negatives are kind of tricky. And y1 is going to be 2, and I'm going to subtract a -1 from, oh, sorry, not subtract, add a -1 to it, and also divide that by 2. So let's take a look at this first piece, the x-coordinate. So 5 plus -4 is the same thing as 5 minus 4, which is 1. So I'm going to write this as 1 over 2. And then I've got 2 plus -1, which is 2 minus 1, which is also 1. So I could leave my coordinate like this, or if it turns out to be a really nice decimal, I could say 0.5 and 0.5. So that coordinate is the exact midpoint of those 2 points if I were to connect them.